A transformation is a general term for four specific ways to manipulate the shape and position of a line, a point, or a geometric figure. The original shape is called the object, and the final shape is called the image.
What is a reflection? A reflection is a transformation representing a flip of a figure. Figures may be reflected in a point, a line, or a plane. When reflecting a figure in a line or in a point, the image is congruent to the pre-image. A reflection maps every point of a figure to an image across a fixed line. Okay, so for this example, we're gonna reflect a triangle over the x-axis. So our triangle is labeled X, Y, and Z. So we're gonna start by filling in our pre-image. So X is at a point -3 and +1. Y is at the point 1 and 4. And Z is at the point 3, 2. Now for this example, we are asked to reflect over the x-axis. So X there is the line that is the horizontal line that goes from side to side, and the line X is represented as the line of symmetry. So what we want to do is reflect the triangle over the x-axis. And the rule of reflection says that every single point in the image is the same distance as the point in the pre-image. So we want to start with point X, and point X in the pre-image is only 1 unit away from the line of symmetry. So we will reflect point X on the x-axis 1 unit from the line of symmetry. So when point X is reflected on the x-axis, X prime will become -3 and -1. So for point Y, we're gonna do the same thing. Now looking at point Y in the pre-image, it is 4 units away from the line of symmetry. So when point Y is reflected on the x-axis, we also need to count 4 units away from the line of symmetry. So the point at pre-image Y would change from 1, 4 onto the image on the x-axis 1 and -4. So finally, we're gonna do the same thing for Z. Now Z is 1, 2 units away from the line of symmetry. So when Z is reflected on the x-axis, it will also be 2 units away from the line of symmetry. So the point at Z will change from the pre-image 3, 2 to the image 3 and 2 when it's reflected on the y-axis. And that is how we reflect our triangle on the x-axis.
Enlarging a shape changes its size. When a shape is enlarged, all sides are changed by the same amount. A 2D shape can be made larger by a given amount. This is called a scale factor. Object can be enlarged using the scale factor to extend the length of the sides because it is the sides that are increased. It is called the linear scale factor.
What is the scale factor? The scale factor tells us how many times larger or smaller the shape will be. For example, enlarging a shape by scale factor 2 means that all of the sides will become 2 times longer. Now I will go into the scale factor and its description. Scale factor greater than 1, the shape gets larger. Scale factor equal to 1, the shape stays the same size. Scale factor greater than 0 but less than 1, the shape gets smaller. Now that we know what the scale factor is, the second thing we need to identify is the center of enlargement. Now the center of enlargement is basically where you identify the point that the two shapes align, which would be the original shape and our enlarged shape. And it also carries coordinates. So it would be one number against another. And it shows where the line can be drawn to connect these two shapes, to show where they line up, and also where the enlargement started, or basically the center of enlargement, where we carried out the enlargement. In our enlargement, we should still be able to see this same thing projected. On the new shape, this side should still be 3 times larger than this side. So for us to be able to do that accurately, we need to use the scale factor. To identify our center of enlargement for this shape, we would have to take a ruler, so you can have straight and neat lines, and draw lines from the vertex or the corner of the shape towards the center. This would be our center of enlargement if we were to just use this as an example. So this will be a little more simple for you. So the coordinates for this center of enlargement would be 0, 0. So we would have to use, from this point here, we will draw lines from here to each vertex, and they must all come through the center here. So as you can see here, I've drawn lines from our center of enlargement, which we use this coordinates for, as an example to make it a little simpler. We've already drawn the lines from each corner to our center of enlargement. Now the next thing we would need to do, we know that our scale factor for this shape, to enlarge the shape, would be 2. What we would need to do is to multiply these two sides by 2 and then extend the lines if they're not at the point to show where we would start drawing this shape. This is to give us a little idea, to give us more information so we can draw our new shape. So let's get that done. Now that we've multiplied the sides, this side has 3 boxes, 1, 2, 3. So we would multiply 3 by 2, which gives us 6. And this side has 1. So we multiply 2 by 1 to give us 2. Now with these answers now, it makes it a little more easier for us to draw our new shape. Why? Because we know that from here, our new shape will start at this point. This will be mirrored back the same way that this one has it here. So these points here, we're starting to draw from here along the center of enlargement. Okay, so we got our answer 6. The next thing we need to do is to count to determine the length of this side. So let's count from this point. 1, 2, 3, 4, 5, 6. So this line has been drawn accurately. We know that this point of the shape here will appear for our new shape here. Our line has been drawn there from the center of enlargement. So that is accurate. The next part we need to look at is the bottom. We multiplied, this was 1. We multiplied it by our scale factor, which is 2, which gave us 2, because 2 multiplied by 1 is 2. So now we have to count from this point again across to get 2. 1, 2. So we know that our next point would be here. That is where we will be drawing. As you can see, we have the 2 boxes there. Where we count the boxes is much easier. So we've already determined the same 3 corners that we found on this shape. We have done the multiplication by the scale factor to tell us the lengths of the sides. So now all is left for us to do is to draw the lines. And there we have it. So our shape now has been enlarged. As you can see, the smaller shape is there, and this is our new shape, fully drawn. We use our scale factor to get the size, and if we check, this side is still 3 times larger than this side. So now that we have seen that these coordinates have been used and our shape has been enlarged, And now we've successfully enlarged shape A to give us shape B. Now all we needed to do, let me just go over the points. You first identify your scale factor, and in our case our scale factor was 2. After identifying your scale factor, we need to mark our center of enlargement. And for our center of enlargement, we use these coordinates as an example. So that would be here. We marked our center of enlargement, and after that, what did we do? We drew the lines from the center of enlargement, attaching it to each vertex or corner of the shape we wanted to enlarge. And after doing that, we used our scale factor to multiply the sides to tell us what would be the length of the sides of our new shape. We did our multiplication, then we used our numbers that we got here. This would have been the side here, our larger side, and this would be for the shorter side. All we had to do next was to count our boxes to go up to give us this length, and the boxes across to give us the length for the bottom, and that's all.
Example of reflection in real life. A real life example of reflection is looking into a mirror. When a person looks into a mirror, the light rays from the body hits the mirror and are reflected back into the person's eyes.
One thing you might be wondering is, what is an example of enlargement in my day-to-day life or my daily life, or how does enlargement apply to real life? So 2 examples I'll be introducing or talking about today. One of them would be the projector. Now, as you can see in the image above me, we have a projector. And what does it show? The movie that the person is looking at is on a phone, which we commonly know has a small screen. Now, with the help of the projector, it can make the image larger. I bet you haven't thought about that as a daily life example or a real life example of enlargement. Now, another example of enlargement, zoom. Now, when we use the camera on our phones, on any device that we would use, which more specifically would be phones or tablets, things that you can carry around, we are able to zoom in and as close and as far as possible as we choose to. That is also an example of real life use of enlargement, because if something is further away from you and you use the zoom, it makes it appear to be closer, or vice versa. If something is closer to you and you zoom out, it makes it appear to be further.
In this part of the assignment, I will be showing you how to teach reflection using teaching materials. The teaching materials that I will be using is a sheet of cardboard, paper, and on this paper I would have drawn up a graph. I would have labeled the graph Y and X, and I would have also set out the points of letter A, letter B, and letter C. First thing to note is that we will be doing reflection of the triangle ABC in the y-axis. So therefore the reflection will be shown on this side here, which is the y-axis. So the point that we have here is A. For 8 we have -8 and 2, -3 and 2, -3 and 8. Now, to find out what our A prime and B prime and C prime will be, you will only do the reverse for the Y point. The X points remain the same, but you will do the inverse for the Y point. So since this is 2, the prime for 2 will be -2 over here. The prime for here, the Y point for B is 2. So for B prime, it will be -2. The y point for C is 8. So for C prime, the point would be -8. So based on this information now, we can now go ahead and plot our point. So let's plot A, B, and C first. So A point is -8 and 2. So let's find that. -8 as in the x and y is 2. So it's -8 and 2 down here. So this is the point there. Next one is -3 and 2. So -3 here and 2 down here. Next point is -3 and 8. So -3 coming up to 8. And then we will therefore connect these points. So let me connect them. So we connect. So I would have just connected the points. So now we can use our cardboard here and cut out the shape of a triangle. Fit it in. I would have finished cutting out the cardboard. So I'm now fitting in the triangle. Good. So I would have fit in the triangle. So therefore, the other triangle should be looking, the other triangle that's supposed to be here, because we're doing reflection in the y-axis, it's supposed to be in the shape of, let me turn it. It should be like this. So let me plot the points to see if it's gonna look just like this. A prime, we have -8 and 2, so -8 to where? For B prime, we have -3 and 2, so we get the here. For C prime, we have -3 and 8. So our point will be here. So let's connect the points. So I would have connected all 3 points for A prime, B prime, and C prime. Now we're using our teaching. So if you want to check to see if our shape is accurate, if we fit this in here, you can see that it is accurate, right? So this is how we can use simple materials in our classroom to teach reflection. Also remember that this line here is the mirror line to show that triangle ABC is being reflected over here, right? So the mirror line part of the 2 triangles. So this is a simple way how a teacher can use our teaching materials to teach reflection to her kids for them to understand. So if the triangle is faced like this, she can simply upturn it, right? Upturn a triangle, and she will know that, the child will know that when you upturn the triangle, it faces like this, it should look like that. So this is a simple way in which they can use to teach reflection.
Okay, well, this is an example of a teaching material that we can use to teach enlargement. This is called a geoboard. Now on the board you see that there is something here to represent the y-axis and the x-axis. Is there x and y? And now to use this board to show the shapes, we have these little black pegs that we put into the holes like I've done here already to show. And then we use the coordinates. We find our center just the same way that we would have done the example. So this way now the children can manipulate using the rubber bands to form their shapes and to show the enlargement of their shapes. This would be a great teaching material with hands-on activities to teach enlargement.